Hello and welcome back to another contribution to my Cinematic Unity series. Today I want to take you on a bus ride through a medieval desert village or town. As usual, I will begin by naming all the required resources that I'm tapping into to make this project possible. For this, let me switch over to my browser. I started the landscape using this open texture library. It has some very nice textures in it, and primarily I'm using this desert sand, which is nice and toony to get this cartoon look to it. Next, of course, central component is the medieval desert city. I am not actually using the city that comes with the project. I wanted to build my own. Now, don't laugh at me. This is one of my very first times I actually tried to create my own environment, and I'm not an artist, so just be patient. Maybe in time I will be able to do a good job. Anyway, this is a great asset to have if you enjoy cartoon style buildings. It has 100 models in it, and lots of props like trees and fountains and balconies and stuff. So even if you use the same building 5 times, by adding something onto them and recombining them and maybe putting a balcony on one and not on the other, etc., you can make it look very different and individual. Next on the list, I said a bus ride is, of course, a bus. Now, as you can see, there's 4 cars in this package, but that's not what it's all about. What's really interesting about this package is that it's a real physics simulation of a car. This will really behave like a real car. So that you can hear the bus springs when you go over terrain that is not so even. You can hear the creaking of the springs of the bus. It goes into so much detail. And of course, the racing cars, which I'm not so interested in, are real racing cars with all the attributes of sliding and everything. So this is a great asset to have. Unfortunately, it's a little bit expensive, but I think if you're going to do anything regarding cars, you want to get this. Next on the list is I want to record the trip through the city so I can sit back and just enjoy the ride without having to drive the bus. So, of course, I'm using my own real-time recorder to record the whole thing. Then for the bus, I wanted to have a driver, and of course, I can't make my own characters. But Mixamo, I'm not sure how it's pronounced, has a whole list of characters, and I've chosen a police officer because he has a blue uniform, and you could mistake him for a bus driver, especially if you only see him from behind and don't look at his badge. And last but not least, I just got this wheel. Thrustmaster Ferrari 458 Italia. And this wheel will be used to actually drive the bus. I'm going to sit down in the bus and drive it, literally. Of course, I will do that in VR, so I can look out the window to my left, to my right, and see if there's any obstacles, which you really need when you're trying to drive a car. So all this is going to be put together, and I'm going to explain every single step of the way. In the background, you can already see the medieval village or town that I've created. It has a path going this way and around and back, and this is the entrance. But I'm not going to go into how to build that because obviously either you already know or you're going to not want to watch my video for this. I would like to focus on the bus. This is the bus. I've changed the color. It's normally green, but it's really pretty much the original bus. And as you can see, there's already someone sitting at the wheel. But now, how do I control this bus? How do I drive the bus? Now for that, you need to remember how the Unity input system works. Let's have a look at project settings and input here. You have a number of axes. Let me just open this a little bit more. And now you see I entered a new number here. Normally I think it's 24 or something. I put in 30, and all the stuff that I want to use I put here. Button A, B, X, Y, down, up, etc. Now let's see, how did I find out how to do that? Now fortunately, the wheel that I bought was built originally for Xbox, and it has a normal USB connector. So when you plug it into your PC or laptop, Windows will actually recognize it, because Xbox is Microsoft and Windows is Microsoft. So of course it will be recognized as a game controller. Now in order to see that, you have to type in here game, and there you see set up USB game controller. So I'm going to click on that. And what you get here when you go to properties, you get this little test screen, which is great. Now watch. When I turn the wheel, you can see this little, see that here, this little plus sign, move all the way to the left and all the way to the right when I turn the wheel. So this is my x-axis. And then when I press the throttle, the z-axis goes all the way up. And when I press the brake, it goes all the way down. So 0 means idle, +1 means full throttle, and -1 means actually reverse. Okay. Then all the buttons, I'll press a couple. That's A, B, X, Y, etc. And you see there's a number. For Y it's 4, and for A it's 1. So now if you compare, over here I set up button A. I called it button A. I'm free to do whatever I want. Now this is important though. I have to open it up even further. Joystick button 0 with the blanks in between. It has to be exactly that name. And then you have to say it's a key or mouse button. And the same goes for button B. Let me just close this so we see more. Joystick button 1, etc. So those buttons 1, 2, 3, 4, 5, they actually map to something here. And now we get to the wheel. Now the wheel was an axis, a joystick axis. It's the x-axis of this joystick. It's not really a joystick, but it behaves like a joystick axis. And that's really all you have to know. Now you can change the sensitivity and stuff if you're not happy with the way it moves. So you may want to play with that a little bit in your game or whatever you're making. So if you look at the bus, you will see there's all sorts of things you can set up, and particularly what you can set up is the input. Here, this one. Open that up. Oops. And there you can see throttle and brake input are just one axis, which is what I have. Obviously, there are some controllers out there that have more than one axis. I'm using the same single axis method as is prepared here, but they can have separate. Then the steer axis, I called it wheel, remember? here, wheel. And that name has to be typed in here. And for the throttle and brake, I used speed. And the handbrake is one of those extra buttons. And I'm not interested in reset. I never even pay attention to that. So that's already the full setup for the bus. With this, you can actually drive the bus, which I'm not going to do now. I'm going to save that for later. We have a bus and we have a driver, but the driver is not actually driving the bus yet. If I don't do anything, this bus driver will just sit in his idle position forever and not actually do anything. So how do I get him to hold the wheel and steer the bus? Now for that, we have inverse kinematics. Now if you look at the figure, there's a controller, and it just has an idle animation, of course. But if you see here, it says IK. That's here, IK pass. This has to be checked because now we can override the idle animation at certain points, which is the hands and the feet, basically. Of course, you can override other parts too, but this is basically what is meant to be overridden. So I could attach his hands to the wheel somehow and make them move with the wheel. Now, of course, if you watch people drive with two hands, the hand will go hand over hand as you turn the wheel, which is really complicated, and I don't believe in complicated. I believe in simple. So I decided this guy is really cool, and he's gonna drive this bus with just one hand. And for that purpose, I have added a location to this wheel. I have like a child here, and I called it wheel hand position. Let me make that visible there. And as you can see, let me come a bit closer. It's at this point of the wheel and a little bit underneath. In a moment, you will see why. But let me just go on a little bit, and then you will see how I use that. Okay, so it's a wheel hand position. So this guy needs a script to do the inverse kinematics to move his hand over to this hand position. Because when the wheel turns, and this car simulation is so good that the wheel actually does turn when you steer to the left or to the right, it will actually turn, and so the hand will move along with the steering wheel. So all you have to do is attach it. And for that, I wrote this little script, which in my infinite ingenuity, I called hand on wheel. And as you can see, it gets a wheel position. That's the one I just showed you here. Wheel hand position. This one is in here. So I have a wheel position. So let me just change over to this. Now you can see here's the wheel position, public transform, da da da. And in awake, all I do is get the animator. And then instead of update, I get a call called on animator IK with a layer index, which I'm ignoring. We don't have one layer, so I don't care about layers. So what you have to do is you have to tell the animator that you're going to set an inverse kinematic position with a certain weight. The weight is used to calculate between the original movement and the inverse kinematic movement. And 1.0 means I completely override the idle animation at this point. The hand will do exactly what I tell it to do. There's no blending with the original animation. And then, of course, I set the position. Now, those two lines I will discuss in a moment. But just with the position for the right hand, I just put in the position of the wheel. And that should do the trick. I'm setting an absolute position. This is an absolute position. So that's going to match. So let's go back and run this. and look at the result. Hello, sir. May I watch you while you drive? Okay, there you can see there's the idle animation, and he's just going to sit there forever. But now I'm turning the wheel. You can see the hand is being pulled, sort of the way I want, but not really the way I want. Now, why is that so? Because the inverse kinematics actually work in a different way than I want. The inverse kinematics will move the hand. Now, if you look at the hierarchy of where the hand is located, you will see, let me just go in. There's hips as the root, and then spine. It's the right shoulder, right arm. Just go in. Okay, that's it. Right hand. Now look closely. The right hand is actually down here, not there where the fingers are, but down here. But we have a finger here, which is the thumb. That would be the perfect place. That's where I would want to place the hand, where the thumb is. Unfortunately, inverse kinematics automatically looks for the hand and not for the thumb. So I did a quick and dirty fix for this. I believe in doing things as simple as possible with maximum effect. So what I did here is I calculated an offset between the hand position, after I set the inverse kinematics. I set the hand position indirectly by set IK position. So I get a hand position and I subtract the thumb position. So now I do the same calculation again, set inverse kinematics position, but now with actually an offset for the thumb. And that looks much better. I'm not saying it's perfect, but it certainly looks better. So let me just start this one more time. Now, as you can see, his hand is now resting. Well, actually, his thumb is now resting where I want the hand to rest. And that looks, let's say, acceptable. So now we have a driver. I must admit I'm a bit of a perfectionist, so of course the hand movement is nice, but I also want his head to turn. Otherwise he looks so dead when he drives the bus. So let's revisit the inverse kinematics function one more time. I added a couple of things that I want to show you. Here we are. So this is still as you've seen it, set IK position once, set IK position second time with the offset. Then the next thing I do is I have set up a recording. That's the data file recording. And if I'm in recording mode, I will record the rotation of the head. Or if I'm in playback mode, I will play back the rotation of the head. It's as simple as that. But in order to actually affect the head, you have to say set bone local rotation, because you have to do this on Animator IK. If you try to do it in an update function or something, or player recorder kind of construction like I usually do, it's not going to work, because the entire character of the bus driver, or rather police officer, is being driven by the animation, and I have to override it. And the only way to do that is within this function on Animator IK. Okay, so this little calculation is because I need to have some kind of a zero position for the head, so I know how it's being rotated in world coordinates. So I do this little calculation. I go inverse from the camera rotation, which is really the head-mounted display that I'm wearing while I drive the bus. And I go to world with the inverse, and then into a relative position to the driver, which is the calculation here times root bone rotation. And then I changed the sign for X, Y, and Z, and then it's correct. Otherwise, when I turn my head to the left, he will turn to the right, etc. Now, what I still need to do is set up the recording for the bus. Maybe I didn't say it clearly yet, but what I want to do is I want to get behind the driver wheel and drive the bus through the city, record the entire ride, and then just play back the whole bus movement, whatever, with the driver driving the bus seemingly. So I can sit back and just enjoy the ride from a passenger perspective. So that's what I want to do. Now, to record the bus movement, I really have all sorts of options, and I had to think about what's the best option. Now, option number one would be, instead of recording the transform of the bus, I could just record what I do with the wheel and the throttle, the input. Just record all the input, which would be highly efficient, and just feed the bus the input again at runtime. And I actually did that, and I failed miserably. Why? Because obviously the physics in Unity are non-deterministic, meaning you can take this bus ride 3 times in this way, and you will get 3 different rides, 3 different results. So I actually crashed through buildings. I fell down the ravine and everything because at one time the bus was sliding a little bit when I went downhill, and the other time when I went down the same hill with the same input, it didn't slide as much. So when I turned left, one time I turned right past the house, and the second time I went straight into the building. Things like that. So if you're gonna record input, that's fine, and it's going to be beautiful and work, unless you're using non-deterministic effects such as the physics simulation of Unity. If you're going to do that, forget it. It's not going to work. So instead, I decided I record the bus transform. And there I really have 2 choices. I could record everything, like recursively. And as a matter of fact, I could have said that. See here. This is the bus. And I have my data file, of course, Busride. And I could just say recursive. And then I would record everything. But I don't want to do that. It's too much to record. I think all the wheels turning and everything. I'm going to be inside the bus, so why should I record the wheels turning and stuff? So instead, I did a non-recursive recording, but I still want the wheel to turn. So I have another script, another data file for the wheel movement. So I record the wheel movement and the movement of the chassis of the bus. So those 2 will do fine. The wheel, when it turns, will move the hand of the driver. And of course, the bus needs to move through the landscape. So those 2 I record. And this is the bus recorder. And there you can see that's the bus recording. And that's the wheel recording. And this, by the way, is the neck recording. Now I've finally reached my goal. I'm riding in the bus, and the driver's taking care of the trip. I can just walk around. I'll look around. You may notice that, yes, the hand is moving, the head is turning. You may also notice that the quality had to be medium to low to even run this project. I obviously went overboard with the number of buildings I put into the landscape, and well, it's a very jerky video. But okay, I achieved what I wanted to. An experience of a bus passenger in a tourist bus that will take a trip through the medieval eastern village or town, whatever. He actually did a slide there, did you notice? And I can look out the window. It's like a VR experience should be, just experience. Okay, I think I'm going to walk back to my seat and just enjoy the ride. And thank you for watching this video and listening to me. I hope you had some fun and enjoyed this. Talk to you soon again when I talk about Unity and Cinematic Unity.